Now I'm going to share my screen so I can show you guys what is in Schoology. And again, be sure you have out a sheet of paper and something to write with. Today is February the 3rd. We are still in the 4th 6 weeks. Okay. It is a Wednesday. Now, today we're going to work on an assignment together, or at least we're going to get started on it together. It's known as a vector sense-making task. And as always, whenever we do assignments like this, you guys are going to take a picture of it and upload it here to the submission box. Okay. Before I get to this though, there's one thing that I want to talk about before I get to that. If y'all remember last time, I gave you guys the rules for how to add vectors graphically. Angelina, I'm going to explain that term, sense making, in a moment. Give me just a moment. It's just one of the booklets that I have that's called sense making tasks, and I just pulled the assignment from that booklet. But guys, we've already talked about how to add vectors graphically. We talked about that last time. Of course, I went over several examples with you guys. On today, I want to show you guys how to subtract vectors graphically. Okay, so let me open up a new Kami sheet. So guys, whenever we're adding vectors, you guys already know. So let's say I give you two vectors. I give you one vector that looks like this. Excuse me. I give you one vector that looks like this. And I give you another vector that looks like this. Okay. And I ask you to add those two vectors. Okay. Guys, what's the first rule whenever we're adding vectors? What is the first rule?
You gotta like put them against each other's back. Well, not each other's back, but like one back in front of one's front.
Yeah, exactly. So connect them head to tail, right? Kind of link them together like a chain, right? So there's three rules, right? Connect them head to tail. 2, find your starting point and find your ending point. 3, connect the dots by drawing the resulting vector pointing toward the ending point. So, thank you, Jeremiah. So, for example, I'm going to take this vector here, and I'm going to take those two vectors, and I'm going to connect them head to tail. Okay. So that's step 1. You're going to kind of link them together like a chain. Step 2 says find your starting point and find your ending point. Remember, guys, in order to find your ending point, you just follow the direction of the arrows, right? Because the arrows lead you to your destination, right? So you will start here, then you'll go like this. You're going to end up here, then you're going to end up here. So this is your ending point, right? So this is your starting point. Okay, and this right here is your ending point. So that's step 2. And then lastly, step 3 says to draw your resultant vector pointing toward your ending point. Okay. So, okay, that vector right there in red, that's what we get when we add up v1 plus v2. So v1 plus v2 gives us that resultant vector in red. Okay. So that's how you add vectors. Okay. Hopefully that makes sense. But guys, imagine this, that I give you two vectors and I ask you to subtract them. Suppose I give you one vector that looks like this. So I give you one vector that looks like that. And let's say I give you another vector that looks like this. Okay. Now, the green vector is v1 and the blue vector is v2. And I ask you to subtract v2 from v1. So v1 minus v2. So how do we subtract vectors? Okay. Well, whenever you're subtracting vectors, the rule says basically what you do is basically you take the vector that has a negative in front of it and you flip it. this should give you a vector that looks like a mirror image of the unflipped vector. And as soon as you do that, then you just repeat these steps from above. Okay. So whenever you're adding vectors, whenever you're subtracting vectors, you want to take the vector that has a negative in front of it and you want to flip it. Okay. So guys, look at V2. Okay. So this is V2, and V2 is the vector that has the negative in front of it, right? So this is V2. Okay. Whenever we're subtracting vectors, right? If I want to take this vector and subtract it from V1, I'm going to take this vector here and I'm going to flip it, right? I'm going to flip it so that it looks like a mirror image, right? So I'm going to take it and flip it. So in other words, if I take this vector and I flip it, that will look something like this. Again, once you flip the vector, it's going to look exactly like a mirror image. And I'm going to do my best to draw that for you guys now. Okay. So, and again, it's not perfect, but you guys get the idea. So I'm going to take my vector and I'll flip it. And so that vector right there, that is what is considered negative V2. Okay. That vector right there. And then so once you take that vector and you flip it, then you just repeat your steps from above. You take this vector here and you connect it to this vector. You're going to connect it head to tail. Okay, so that's the next step. And then you're going to find your starting point and find your ending point. This is your starting point, and this is your ending point. Starting point, ending point. And lastly, you're going to draw the resultant vector pointing toward your ending point. Okay, so that vector there in red, that is the vector V1 minus V2. And that's all you do whenever you're subtracting vectors. So if you're adding them, you guys clearly see what to do. But if you're subtracting them, you're going to take the vector that has a negative in front of it and you're going to flip it, right? Because when you flip it, you make that vector negative. Taco. Makala, what are you saying? What? Makala, you okay? Anyway, so let's do another example. Angelina, could you give him? Thank you. Thank you, Angelina. Okay, let's do another example. So suppose I give you some vector that looks like this. We're going to call that vector V1. And I give you a vector that looks like this, which we're going to call V2. And I ask you to do V1 minus V2. Okay. So in other words, you're subtracting this vector from that vector. So guys, remember, whenever you're subtracting vectors, the vector that has a negative in front of it, you're going to take that vector and you're going to flip it. Right. So I'm going to take that vector and I'll flip it. So if I was to flip this vector, how would that vector look like when I flip it? In other words, it's going to be a mirror image. So the flip vector will look something like this. And I'm trying to draw this just right. So if this vector right here is V1, and this right here is negative V1. I'm sorry, if this vector is V2, excuse me, then this would be a negative V2. All right, so you just take the vector and you just flip it. Irina, this is not what you're turning in. I'm just going over something. But the assignment is just work you're going to have to be shown. And I'm explaining that when I get to it. So once we do this, guys, so remember, after you take your vector and you flip it, then you just follow the rules where you connect your vectors head to tail. So I'm going to take this vector here. I don't know why is it not there. this is a problem. Come on, let me. Okay, so that's negative big 2. Okay, so take my vectors, have them head to tail. Step 1. Step 2, find my starting point, find my ending point. Okay, that's my starting point. That's my ending point. Remember, follow the direction of the arrows to reach your destination. And then step 3, so draw your resultant vector, point it like this. So that's the vector v1 minus v2. Irina, I'm gonna explain that. I'm gonna explain that when we get to the assignment. I promise. I'm gonna explain that when we get to the assignment. Okay. Right now, I'm just showing you guys how to subtract vectors. All right, guys. So everybody got that? Let me just do one more example before we move on. So suppose I give you guys a vector that looks like this. We're going to call this vector v1. And imagine that I give you guys a vector that looks like this, which we're going to call v2. And then you have to do v1 minus v2. Okay, so remember, this is v1, this is v2. Okay. So if this is v2, remember, guys, whenever we're subtracting one vector from another vector, remember, we have to take the vector that has a negative in front of it, and we have to flip it. Right? So in other words, it's going to look like an exact mirror image. So if I take this vector here and I flip it, in other words, you just change the direction the arrow is pointing. So this vector right here, if I flip it, an exact mirror image of this vector will look something like this. So this right here, this is considered to be negative v2, basically. And then remember, after I take my vector and I flip it, then I combine my vectors head to tail, like this. Okay. And then in this next step, I find my starting point, find my ending point. Again, follow the arrows. Yeah, so this will be my starting point. And this will be my ending point. And lastly, step 3 says draw your resultant vector by connecting the dots, pointing toward your ending point. Okay. So this right here in red that I just drew, that's the vector v1 minus v2. Any questions on how to subtract vectors? Y'all got that? Okay, now let's actually get to the assignment that you guys are going to be turning in. And so be sure you have a sheet of paper out. Preferably, guys, if y'all are able to print this, then I think that's even better, because I think it's better when you guys actually have the grid in front of you and you can count it. But if you guys don't have a printer, that's fine. Also, you can just take out a sheet of paper and you're gonna write everything down. And of course, I'm gonna tell you guys what to write down and how to do this. Okay, now, I have a booklet, an electronic booklet called Sense Making Tasks for Introductory Physics. And so this assignment that we're about to do, I actually just pulled it from this booklet that I have, because this has all kinds of assignments. So I went to the vectors chapter and I just pulled out a couple of assignments to practice on. And so that's where these assignments came from. It came from this booklet called Sense Making Tasks. And so Angelina, that's where the term comes from. It just comes from the name of this booklet here that I have, because it's a booklet that has basically it has a lot of assignments, a lot of assignments that I can just go through and I can just pick what I want. So I just went to the vectors chapter and I just pulled it out. Okay. So this is what we're going to be doing today. We're going to be doing a sense-making task called vectors. It's these assignments is just to they're to help you get a really good conceptual understanding of physics. Okay. All right. So there's a total of 5 of these activities we're going to do. So like you should see 1, 2, 3, 4, 5. And of course, whenever you're turning in your work, just be sure to label everything. So, for example, this will be 1A, 1B, 1C, 1D. And so, and obviously it's easier for me to grade it that way, assuming you're just writing on your own paper. Okay. So, remember, guys, whenever you are dealing with vectors, vectors have both magnitude and direction. Magnitude and direction. All vectors are represented by an arrow with magnitude and direction. So, Irina, whenever I'm talking about the magnitude of a vector, basically what I'm referring to how long the vector is. Magnitude just refers to how long the vector is. With that said, guys, let us look at number 1. And of course, y'all are going to walk me through this. Okay, I'm gonna be taking y'all's lead. Okay, so if we look at the instructions, it says 8 vectors are shown superimposed on a grid. So we have 8 vectors here. So look at 1A. 1A says list all the vectors that have the same magnitude as vector A. Okay, list all the vectors that have the same magnitude as vector A. Okay, so guys, remember what magnitude is. Magnitude refers to the length of the vector. Okay, guys, look close at these vectors here. Y'all tell me, which of those vectors have the same magnitude as vector A? Y'all want to tell me? Kind of put in the chat box. What do y'all think?
D and G.
I'm sorry.
D and G.
Exactly. Yeah, D is 1 and G is 1 as well. Thank you. What's that, you, Irina?
Yes.
All right. Thank you. So yes, D and G. For number 1, you're not going to show me any work. Just write out the answers.
Do we have to write the question?
No, you don't have to write the question. You do not have to write the question. Again, 1A, we're not going to worry about. Okay, so guys, remember, magnitude just means how long the vector is. If you look at vector A is 1, 2, 3 units long. So basically, guys, you're going to count these vectors and you're going to see which one are exactly 3 units long. We see that's true for D. This is 1, 2, 3. And that's true for G as well. 1, 2, 3. Now, of course, this one right here may be pointed in a different direction compared to this, but that's okay. For now, we're not concerned with direction. We're solely concerned with magnitude for this particular question, for 1A. All right, guys, look at 1B. List all the vectors that have the same magnitude as vector B. Anyway?
It's none like it. B's the only one.
F.
Ooh, okay.
F is 4.
I'm hearing different responses.
F is 4 and B is 5.
Yes, exactly. Yeah, Irina, you are correct. So there's no vector that matches B. So there's none. And guys, notice Irina's reasoning. It's okay, Angelina. Notice Irina's reasoning. So if you count this is 1, 2, 3, 4, 5. Okay, yeah. So B is 5 units, but there's no other vector on here that is 5 units long. So can everybody see that? It's okay, Angelina. It happens. I do the same thing. I appreciate you guys participating. Okay, can I move on? Guys, look at C, 1C. List all the vectors that have the same magnitude as vector C.
F. F.
Mm-hmm. Yep. Oh crap. What did I do? Is that the only way? Is it? Yep, it looks
Yeah.
like it. Mm-hmm. Remember, magnitude refers to how long the vector is. D says list all the vectors that have the same magnitude as vector negative A. Well, guys, remember what the negative tells you.
D.
I'm sorry?
Negative D and negative G.
Well, you just want to just put D and G. Yeah, because
Okay.
remember what negative tells you. The negative just tells you your direction. You know,
Oh.
as far as magnitude, as far as the vectors that have the same length, you just want to put D and G. Yeah, so that's kind of so. In other words, the answer is the same as in here. Yeah, because think about what negative A means. Remember what we said? A negative vector means you just flip it. It's a mirror image. So if this right here is the vector A, then that means this right here in red, that vector, this vector that I just drew in red, that is the vector negative A. Right. So negative A points in the opposite direction, right? Because that's because that's what the negative means. Negative means you just flip your direction. In so many words. Okay. So if that's the vector A, that's the vector negative A. But notice negative A is still 1, 2, 3 units long. So that means you're just looking for the answer that's still 3 units long, which will be D and G. Does that make sense, guys?
Yes.
Oh, awesome.
Wait, so since it's still the same length, it's the same answer as A1?
Bingo.
Or A?
Because it's still the same length. Yep. Because remember, only thing magnitude refers to is the length of the vector. When I say magnitude, that's what I mean, the length of the vector. You got it. Magnitude refers to the length of the vector. That this negative here, the only thing this negative tells us is that A switched directions. Instead of being A, it's now negative A, meaning you flip the vector. All right, guys, let's keep going. E and F, you guys can do later on. That's pretty easy. Y'all can do E and F on your own. Look at number 2. Hey guys, look at number 2. Here, guys, you're just going to basically list out the rankings. It says 5 vectors are shown superimposed on a grid. Rank the magnitude of all the vectors. Okay, so guys, go ahead and take these vectors here, count them out, and then you tell me what the magnitude would be according to their rankings. Okay, I already see Jerry has put something.
Wait, what question is this?
This is number 2.
There are A, B.
Hey, Jerry, you're ranking from greatest to least. So go through that again, Jerry. If you go from greatest to least. Yeah, so you're going from your greatest magnitude to your smallest magnitude. Okay. All right, so for those of you guys that are saying B is larger, you are right. So, B has the greatest magnitude, right? Because this is 1, 2, 3, 4, 5 units long, and then after B, notice there's a tie. There's a tie between C, E, and A, right? Because those are all 3 units. And then lastly, D is 2 units. So because C, E, and A are all tied, I'm putting them in the same box to show that they're tied. So B is your greatest. then C, E, and A, and then D has your smallest magnitude. Yes, because there's a tie between them, Angelina. Yeah, it means that they're the same length.
So if we're writing it on our paper, do we just make boxes for them then?
That's fine. Yeah, or just circle it to represent that they're a unit.
Okay.
Yes. So I'm confused. What are you saying, Angelina? Yeah, I'm just saying like you just group C, E, and A together.
Yeah.
Yeah, you just group them
That's what I
together.
meant.
Yeah, because they're tied. Yeah. C, because like this is 3 units. This is 3 units, and then this is also 3 units. Right. So clearly those are tied. Okay. So all right, guys, let's look at number 3. Don't worry about explaining your reasoning here. I want to move on. On number 3, let's look at number 3. This is the one that some students tend to struggle with. So I want you guys to look carefully at these arrows when answering them. So now for 3A, 3A says list all the vectors that have the same direction as vector x. Okay. So guys, what do y'all think? List all the vectors that have the same direction as vector x. And y'all want to, list those for me? I'm sorry?
BEH.
BEH. Okay, everybody agree with that? They have the same direction as vector x. Yes, Irina, you are correct. It is B, E, and H. Okay. And guys, how do we know that? I'm telling you guys right now, whenever you're looking at whenever you're comparing vectors, basically if they have the same slope, they are pointed in the same direction. So, for example, guys, look at this. Look how this vector slopes here. Okay, so look how that vector slopes. Look how this vector slopes. And also look how this vector slopes. Okay. So notice all those slopes match. All those slopes are exactly the same. So since they have the same slopes basically pointing toward they have the same slopes pointing toward the southeast, that means they're pointing the same direction. Okay. Now, sometimes I've had students try to put in F with that, but guys, look at F. Does F have the same slope as E and H and B? Sorry, B has the same slope as well. I'm sorry, I forgot to draw that one. No. So notice if you look closely at F does not have the same slope as B, E, and H. But if you look at it, it's not as slanted. Like it's slightly upward. B, E, and H has a greater slope. So, but it's not F. So that's why you gotta look is that's why you gotta look carefully. Okay, makes sense. Okay, guys, look at 3B. List all the vectors that have the same direction as vector negative x. What do y'all think about this one?
A and C.
A and C? Let's see. So guys, remember what negative x means. Negative x means you just take the vector and you literally just flip its direction. So it's like it looks like a mirror image. So instead of pointing this way, negative x will point this way. Okay. So that I just drew, that is negative x. So the vectors that point exactly in that direction You are right, Irina. It is A and C. A and C. Because if you guys look carefully, A points this way, so it's sloping that way, and then C also slopes that way. So they have the same slope, and they have the same slope, and they're pointing the exact same direction as x, or as negative x. They're pointing toward the northwest, right? Okay. So does this help understand negative vectors now? Well, does it help understand negative vectors better? Like when I say a negative vector, does everybody understand what that means? Yeah. A negative vector just means the vector just flips its direction. Like if it's pointed in one direction, you're going to point in exactly the opposite direction. That's what a negative vector means. You flip the vector so that it looks like a mirror image. Okay. Any questions before I move on to number 4? Okay, guys, here's what I'm going to do. I'm going to do number 4A with you guys, and the rest you're going to do on your own. So you're going to complete the rest of these on your own, including number 5. You're going to do all these by yourselves, but I'm going to just do, I'm going to do 4A with you all, and the rest you're going to do on your own. Okay? Okay, so let's read the directions here. It says, for each situation below, combine the vectors as indicated and determine the direction of the resultant vector. Then select the closest direction to the resultant vector from the direction Rosetta at the right. Here's what we're going to do, guys. On vector A, we're going to add up all these vectors, n plus p plus q plus r, to get the vector j. And we're going to see which of these directions match A. No, Irina, you don't need to draw the graphs. However, Irina, on 4A, I do want you to show your work here on number 4 and number 5, and I'm going to show you what I mean when I say show your work. Okay, but you don't have to draw the graphs. As long as you show your work, you're good. Okay, so, and by the way, guys, in the future, whenever you guys see a letter with an arrow over it, that means that is a vector. So we're going to call J a vector. Okay, that's what that means. So now, in order to get vector J, in order to know the direction that vector J is pointing in, if we add up n plus p plus q plus r, we want to figure out, when we add that up, which of these arrows closely resembles that final direction that we find for J. Okay. Now, there's 2 ways you can do this, guys. Obviously, you can kind of look at all of these vectors, and you can imagine in your head what would happen if we connected those head to tail, head to tail, head to tail, and we found the resultant vector. How would that resultant vector look like? So you can think of it that way. Or what you can do, you can find the x and y components of each of those vectors and add them up, and that'll give you an idea how the resultant vector is going to look like. The second method is the one that I'm going to do with you all, because obviously it's hard to imagine, 4 vectors in your mind, combined head to tail, head to tail, head to tail, and finding the resultant vector that way. So we're just going to look for the x and y components of each vector, and this is what I want you guys to do here. Okay, so guys, let us start with vector n. So with vector n, we want to figure out, what are the x and y components of vector n? Okay. Guys, I'm going to zoom in here. Okay. And I'm going to look at vector n. Okay. Can anybody look at that vector right now, tell me what its x and y components are? Anybody got an idea? Oh, no, not 4, 1, Irina. You're close.
3 and 1?
Yeah, 3, 1, exactly. Right, because guys, remember how to find the x and y components of your vector. You're going to count the number of squares between your starting point and your ending point, right? Because like if you look at this right here, guys, this vector here, this is our starting point. Remember, you follow the arrow to your destination, to your ending point. So this is my ending point. So we're going to count the number of squares between those 2 points. Okay. And of course, you always start counting the x in the x direction first. So we move 1, 2, 3 units in the x direction. Then we go 1, 2. I'm sorry, 1 unit up. So 3 units in x direction, 1 unit up. So yeah, so the vector n, if you guys notice, the vector n, this right here, this is the vector 3, 1. Okay. Y'all got that? Now, awesome. Now, let's move on to the vector p, right? Because we want to add up all these vectors. So let's look at the vector p. Okay, so guys, just by looking at the vector p, can anybody see what that one is? I'm seeing different results. I'm seeing some people saying 2, 3, some people saying negative 2, 3. No, what was it, Irina? Yeah, yes, Irina, that second one, you are right. Okay. Right, you are right for the second one, because remember, guys, whenever you're counting vectors, you want to count. Yeah, thank you. I just realized that, Irina. Yeah, so whenever you're counting vectors, all you're doing is just you're counting the amount of squares between your starting point and your ending point, right? So in order to go from here to here, remember, we're going to start counting in the x direction first. Here we have to move over to the left. So we start off moving to the left. So that's going to be 2 units to the left. So that's negative 2. Angelina, that's negative 2. And then from there, we're going to go up 1, 2, 3 units. So that means P must be negative 2, positive 3. Negative 2, positive 3. I got that? Because remember, in order to get from this point to this point, we had to move in the negative x direction, then we move in the positive x direction. Okay. Anthony, can you just explain your question? What do you mean?
Oh, because I was confused about the negative 2, so I wanted to know, like, if you can tell when a vector is negative by the direction that it's in. Like, for example, Q, you said is going to the left by 2, so then it's negative 2.
Q or P?
Oh, wait, P, my bad, P.
Yes, so P, so P, yes, so Irina, in order to get from this point to this point, notice we had to move 2 units to the left, right? Because yes, so if you move either left or down, it's negative. If you move either to the right or up, it's positive. Does that make sense?
Yes.
Okay. So you're just looking at how you're getting to your final point, right? So what I would do, you would again draw your first point first, and then draw your second point, and then as you count to go from one point to the next, so you right, because and remember, you start moving in the x direction first. So in order to move in the x direction to get from this point to this point, I have to move to the left, which means that's negative. And since I moved up to get here, that's going to be positive in y. Does that help?
Yes, that helps.
All right. And thank you, Irina, for that suggestion. Any other questions? Those are some good questions. Everybody else, are y'all good? Everybody, can I move on? Are we good? Again, guys, don't hesitate to ask me questions. That's what I'm here for. I am here to assist you. What is Q? Just about, guys, y'all should be able to look at Q and see what that is. I'm gonna zoom in on Q. What do y'all think?
-1.
Yep, -1 what?
0.
-1 0, exactly. Because here's like, remember, this is my starting point, and this tip here's my ending point, right? So in order to go from here to here, I have to move in the negative x direction. But I notice I don't go up at all. Like, I'm not even going up because I don't have any y components on Q. So this vector here, Q, is -1 0, right? Since I'm not moving at all in the y direction, I'm going to call that just 0. Okay. What about vector? Lastly, what about vector r? Okay, Irina, you see it 2, -2. Is that correct, everyone? Everybody agree with it? Right, so if you look at r, here's r starting point, here's r's ending point. You want to count the amount of squares between the starting point and the ending point. And so, yes, that means Irina would be correct, guys, because, you know, in order to go from my starting point to my ending point, remember, you start moving in the x direction first. So here, notice I'm going to have to move to the right. So notice there I moved in the positive x direction. But notice from there I'm going to have to move down. So that means I'm moving in the, basically I'm moving in the negative y direction. Right? So that's +2, -2. +2 for x, -2 for y. So that means r is 2, -2. Before I move on, I want to say this. In the past, in the past, some students want to know, well, does it matter which quadrant the vector is in whenever you're labeling directions? Like, no, you're not looking at the quadrants. It doesn't matter which quadrant it's in. As long as you know how to count between your starting point and your ending point, it should be obvious what's negative and what's positive. Okay, I just want to make that clear because I know I've had that question asked in the past. Okay, now we're almost done, guys, because it says, and again, I want to see this, guys. Whenever you guys are showing your work, I want to see that you list out each vector. Okay, so now for this, it says we now have to find the letter J. The letter J is N plus P plus Q plus R. So, guys, look at N, P, Q, and R. When I take those vectors and I add all those vectors up, what do I get for the vector J? Anyone want to tell me?
Is it going to be 2, 2?
Yeah, that's what I got.
Yes, it is going to be 2, 2. Yes, it is 2, 2. Irina, you put 2, 2 at first, but then you put 0. I was confused why you did that. Yeah, it is. It's 2, 2. If you
I wasn't trying to type it.
Okay, now you're good. Yeah. But yeah, it's so when you add up, so you're going to add up the x components and you're going to add up the y components. When you do that, you're going to get the vector 2, 2. Okay, so everybody got that? So in other words, guys, if I have to draw that vector on this grid, how would that vector look like? Well, so what I'm going to do, I'm going to start drawing my vector from the origin here. You don't necessarily have to start drawing your vector from your origin. Um, I just want to do it on this one because that's how they drew theirs. So what this is, you're going to go 2 units to the right, okay? And then you're going to go 2 units up. Okay? So it should be obvious here that this is our ending point. Okay, so this is our starting point. This is our ending point. Okay, and then from there, you just want to connect those dots. Okay, so you just want to connect those dots. So basically, like that. Okay, guys, that vector that I just drew, that is the vector J. Okay. Everybody see what I did? The vector 2, 2 is the vector J. So in other words, guys, what this is saying is, guys, if you took all of these vectors, these 4 vectors, and you link them together like a chain, head to tail, head to tail, head to tail, and then draw, and then once you link that chain together, you can easily connect your starting point and connect your ending point. When you connect your starting point and connect your ending point, the resultant vector will look something like this. It will look like vector J. That's essentially what we're doing. We're combining all these vectors to get that single vector that we're going to call vector J. Okay. So, so guys, now we're going to answer the final question. The final question is, so the final question is, which vector? So guys, so look at this Rosetta off to the side here. Which one of these arrows here best resemble that arrow J? And I think Irina already put it in the chat box. So you guys notice what Irina says. Vector B matches that vector there. So right, so yes, Irina is correct. And good job, Angelina. Good job for agreeing with Irina on that one. So this would be.
Wait, what is y'all?
B. Huh?
Nothing.
So did y'all see what I do? Did y'all see what I did? So it says select the closest direction that this arrow matches with this Rosetta. And of course, this arrow here matches B. Okay. Any questions? Any questions? Awesome, awesome. Yeah, vectors are pretty easy. But I mean, even though vectors are easy, they're really, really useful. Like you'll be surprised, like especially if you major in science or math in college, you'll be surprised how often you use vectors. Even though they're easy, they're really important. They're very important. I cannot tell you how important vectors are, which is why Mr. Becksmith is going to go over them in his class as well. Now he's going to go in much more depth than I do. I just cover the basics that you guys need to know for pre-cal. You're going to use it probably in your early classes, but not so much, Irina. Probably in your earlier classes, you're going to use it as a marking major. Like your earlier math classes, you will. Oh, one more thing I want to ask you guys, because students, I don't know, for some reason, students always seem to forget this. Guys, if I asked you guys right now to how to find the magnitude of this vector, how would you do that? How do we find the magnitude of the vector? So we know the x and y components is 2, 2. How do I find, y'all? Please don't tell me I forgot this. How do I find the magnitude of the vector? Please, someone tell me.
You gotta use SOHCAHTOA.
No, you will use SOHCAHTOA if I gave you the magnitude and you wanted to find the x and y components. You will use SOHCAHTOA in that case. But in this case right here, we know our x and y components is 2, 2, and I'm asking you to find the magnitude. So in that case, what would you use? Come on, guys, we went over this last time. Use Pythagoras Theorem. Thank you, Iman. Pythagoras Theorem. Please, guys, don't forget that. Anytime I ask you to find the magnitude of a vector, you would use Pythagoras theorem. So in this case right here, so we will use a squared plus b squared equals c squared, right? So it's obvious that if this side is 2 and this side is 2, we will want to use Pythagoras theorem. 2 squared plus 2 squared equals c squared. This is 4 plus 4 equals c squared. So this is 8 equals c. So guess what that means? That means c is square root of 8. Okay. So that means, guys, if I want to know how long this vector is from this point to this point, it's just square root of 8. Guys, please remember that. Anytime you know the x and y components and you're asked to find the magnitude of the vector, you would use Pythagoras theorem. Now, of course, guys, if I ask you to go backwards, suppose I give you the magnitude and I ask you to find the x and y components, then you would do what Jeremiah suggested. You would do SOHCAHTOA. Okay, you would use trigonometry. So are we good? Everybody got that? Again, I just wanted to throw that out there. Just so. Okay, awesome. Now, guys, I'm gonna say something on number one. Before I let you guys go, whenever you guys get to number 5, if you're filling out your answer on the sheet of paper here, if you printed it up, on number 5 it asks what is the x component and what is the y component. On this one, that's super easy to find the x and the y components. Basically, what we did here, like how we found the x component and the y component here. If you guys are filling this in, then you would just fill it in here. Assuming you guys print out this paper and you're filling it in. All right, guys, so just complete the rest on your own. And then as soon as you guys get done, you're going to take a picture of everything, upload it into Schoology. Any final questions for me?
Wait, is there a question 5?